Welcome once again. We are still on ionic bond. You see, we are taking my time on bonding because I told you from one of our previous videos that it gives us understanding of how God created almost all the things or substances on this earth and the attractions that hold us all together. So we need to understand each concept under bonding. So still under ionic bonding, in our last video, we talked about 3 out of the 4 things that we need to understand about every bonding or every compound that exhibits some kind of bonding. So we have, under ionic bonding, we have treated the nature and the formation. We have treated the intermolecular forces. And then, of course, we have treated units occurring at the lattice site or the lattice point. In this video, we are going to concentrate on the examples and how to write the formula or formulae of ionic compounds. It's simple. I told you that the formation, the nature, it is usually formed between the atoms or the elements on the left side of the periodic table who have very low ionization energy and therefore can easily lose their electrons. By losing the electrons, they assume an octet or duplex state, become very stable in that state. And those elements on the far right, with the exception of the group O elements or the noble gases, the group 7, group 6, group 5, normally the group 7 and the group 6 and the group 7, they also have high electron affinity. They want to gain electrons and fill their octet or duplex state. Normally they are octet state. So they become stable. And once this happens, the transfer of electrons from the elements of low ionization energy to the elements of high electron affinity and high electronegativity creates some ionic characteristics. Positive ions for those on the left who have lost the electrons, negative ions for those on the right that have gained electrons, and the two are attracted by the electrostatic force of attraction. So examples, you could combine any element here with any element under group O, but you have to know how to do it. In ionic bonding, the positive charges must balance the negative charges. You cannot write an atom that will form +2. Okay, if I take the group 2 element, for instance, if I take magnesium being group 2, when it's going to lose electrons, will lose 2 electrons. You cannot write this as an ionic compound. You'll be crucified. But if you write this for me, I'll not only mark you and give you 0, I'll even give you a negative answer. In the sense that this one will lose 2 electrons and this one cannot gain all the 2 electrons. This one is in group 7 after gaining just 1 electron, that is all. So what will it do? It will bring its other colleague for them to be 2. So that whilst one chloride takes 1 electron from the magnesium, the other chlorine will also take the other electron from magnesium. So in doing so, the formula for magnesium chloride cannot be just magnesium chlorine. It will have to be magnesium chloride. Where when I'm writing it in actual science, it would be magnesium would have lost 2 electrons. Each of these chlorine would have lost 1 electron. So don't say that, why is this +2 and this is -1? No, there are 2 of this there. So the 2 atoms here, or the 2 negative, means that the negative charges here too is -2. And that balances the +2. So that is the actual formula of magnesium chloride. So now, let me give you some general formulae. For the group 1 elements, because they have 1 electron in the atom shell, they can always lose 1 electron. When they are combining with group 7 elements, because they also need only 1 electron, the formula is that M plus X minus. That is my formula. Get this very well. This simply means that this is a group 1 element and that is a group 7 element. So any formula that you can write out of this formula, any chemical combination, you pick a group 1 element and pick any of the group 7 elements. You put them together, you are right in forming an ionic compound, example of an ionic compound. So if I decide to write examples, I could take lithium for group 1. So I write lithium, the first element under group 7 is fluorine, isn't it? So lithium fluoride, perfect. Lithium is +1, fluorine is -1. So again, if I take lithium, I combine with the next element down there, that is what? Chlorine. I can again take lithium and combine with the next element there, that is bromine, that is correct. I'll take lithium and combine with the next element there, that is iodine, that is also correct. From this formula, by using only lithium, I've been able to write with fluorine, with chlorine, with bromine, with iodine. There they are. Fluorine, chlorine, bromine, iodine. I could go down. All these are ionic compounds coming from this formula that I've written here, where I'm saying that I'm defining my M here to be a group 1 element. That is, when they lose their 1 electron, they become +1. And when X is my group 7 element, when they gain that 1 electron, they become -1. So out of this formula I've written, I'm going to be able to write several examples by just combining the group 1 with all the group 7, another group 1 with all the group 7. So from here, if I take sodium 2, I can write sodium fluoride, I can write sodium chloride, I can write sodium bromide, and I can write sodium iodide. They are all examples of ionic compounds coming from this formula. So that is one formula for writing several examples of ionic compounds. So even if we are asking the question, write 10 examples of ionic compounds, just remember this, and out of this derive your various examples. In the same sense, I could take potassium and then go. I could also take rubidium and combine them all. All these are examples. I hope you are okay following the examples. Where this potassium is this group 1 element, rubidium is this group 1 element, cesium is there. I could go and write all of them. Now, another formula that we can derive from here. Another formula, I'm going to change the metal. I'm going to change the metal. Another example, will be, I'll take group 2 element and combine with group 7. So in that case, if I write M2 plus, this time my M here refers to a group 2 element. The M refers to what? A group 2 element. My X, if I put minus here and put 2 here, this is still referring to a group 7 element. So let me put here group 2, group 7. Now why am I putting these 2 here? It is telling me that if the group 2 element, because it is in group 2 and can lose 2 electrons at the same time, not 1, when it loses the 2 electrons, if it is going to combine with a group 7 element, which can absorb only 1 electron, or who can accept only 1 electron, you need 2 of such atoms of group 7 for each one to accept 1 electron from the group 2 element. So this formula I've written here is the formation of ionic compounds involving a group 2 metal and a group 7 non-metal. So you can see that ionic bonds are normally formed between the metals and the non-metals. So from this, I will not use beryllium because later I will explain beryllium doesn't form ionic compounds. So I'll skip beryllium and start with magnesium. So magnesium, if I start with the first element of the group 7, which is fluorine, I need 2 of the fluorine atoms to accept this. So here I've written magnesium. Magnesium, where is it? Located on the periodic table, group 2. How many electrons can it lose? 2. Fluorine, where is it located? Group 7. How many electrons can it accept? 1. So you cannot have only 1 atom of fluorine accepting the 2 electrons. So you need to multiply the fluorine by 2. So this simply means that this is +2, that is -1. If I put a comma there, I can have magnesium chloride, that also have to be 2. I can have magnesium bromide, that also have to be 2. And I can have magnesium iodide, that will have to be 2. From this formula. Then I can go to the next element on the group 2, calcium fluoride, have to be 2. Calcium chloride, it will have to be 2. Calcium bromide, bromine have to be 2. Sorry, this one is bromide, so Br2, Br2, and then calcium iodide 2. That is not the end of the examples of ionic compounds that we can form. So again, I can go back to group 1 and group 2 and come and take group 6 elements. So I'm going to clean this and give you another large volume of examples using another formula. Here I'm going to write my M plus, referring to group 1. I want to form a compound with group 6 element. Group 6 element, where does it start from? Oxygen. Okay, group 6, oxygen, sulfur, selenium. So group 1, if I'm forming an ionic compound with oxygen, oxygen being group 6, how many electrons does it need to fill its octet? It needs 2 electrons. So a group 1 element cannot just come and donate its 1 electron and say, my brother, I've made you happy, so let's form a bond. It will tell you, no, after accepting that 1 electron, I'm not so happy because my octet is not filled. Go and bring your other friend to donate 1 more electron before I, group 6 element, I'll be happy. I'll have my octet filled. So for group 1 element combined with group 6 element, the group 1 will have to be 2 and the group 6 will have to be 1. This is group 6. So after losing 1 electron, it becomes plus. The other element must also lose 1 electron for the group 6 element, which needs 2 electrons to fill its octet, to accept them. So here you have 2 of this combined with 1 of that. Each one of the group 1 element donating 1 electron, and then that will be 2 electrons. Now the group 6 element, which is the oxygen here, will accept the 2 electrons before it becomes fully filled, and therefore they can form the ionic bond. So here the formula is plus 1 minus 2. But because there is 2 here, then it means that you are getting plus 2. In other words, it is plus 1 times 2. That gives you plus 2. And it combines with the minus 2. So out of this formula I've written here, let's see the examples I can write. It's a group 1 element. So lithium 2 oxide. Lithium 2 sulfide. Okay, and then if you want, you can add a third element, selenium. Another example is where I take a group 2, M2 plus, that is group 2. Now group 2, when I'm combining with group 6, because group 2 can donate 2 electrons at the same time, and group 6 can accept the 2 electrons at the same time, the ratio becomes 1 to 1. So if I bring here, sorry, here let me still use my X, please, so that the specific example will be oxygen, my X2. So X here, my X here is representing group 6. So my group 2 element, if it is going to combine with X here, which is group 2, group 6. If this is group 6, then this will have to be minus 2. So M2 plus, because it's a group 2 element, losing 2 electrons, combined with a group 6 element which can accept 2 electrons, that is the formula. So because this will cancel this, when we are writing the examples, it may not be necessary to bring them. So we can write for group 2 element, magnesium oxide. This is telling me that magnesium is plus 2, oxygen takes minus 2. So in effect, this is plus 2, minus 2. Balance. I could also write magnesium sulfide, minus 2 here, plus 2 there. If you want, you can just leave them out. So with group 6, these are the examples that I can give. I'll not go to group 5 with any of these, because group 5 Yes, they can accept 3 electrons, but it's sometimes difficult for one element to come and then give 3 electrons all to it. So normally they will form covalent compounds. When we come there, we'll see it. But of course, let me say that group 3, aluminium, also forms, group 3 aluminium also forms some ionic compounds. The boron sitting on top of aluminium doesn't form ionic compounds. Just as when we came to group 2, beryllium can lose 2 electrons, but because of certain reasons which will come later in our videos, beryllium doesn't form ionic compounds. It forms covalent compounds. Again, when it comes to group 3, boron could lose 3 electrons and form ionic compounds. Again, that also, just like beryllium, doesn't form ionic compounds. It forms covalent compounds. But aluminium can form ionic compounds. And for aluminium, let me just choose that group 3. Aluminium, because it is in group 3, it can lose 3 electrons. And if it is going to form that compound with a group 6, like chlorine, they need 3 of chlorine atoms. I've explained that. So chlorine will have to be 3 minus. So aluminum loses the 3 electrons, and then you need 3 chlorine atoms to accept each 1 electron each from aluminum. So minus 1 times 3 of these atoms balances this to be minus 3 plus 3. Okay. What about aluminum, a group 3 element, and then group 6? Let's see. Now, aluminium plus 3. If you want to form a compound with a group 6 element, for instance, remember that oxygen can take 2 electrons. So if oxygen can take 2 electrons and this one can donate 3 electrons, what do? To balance it, just bring the 2 here and bring the 3 here. So 2 of this and 3 of that will then balance each other. So this is telling me that 1 aluminum atom each will donate 3 electrons. 1 oxygen atom can accept only 2 of that. It's left with 1 electron hanging. But when it is balanced like this, it means that 2 aluminum atoms coming together will donate a total of 6 electrons to become plus 6. That is plus 3 times 2. And 3 oxygen atoms will then come and accept all the 6 electrons. In other words, each of the oxygen atom will accept 2 of the electrons. So minus 2 times 3 will give you 6. So this is the formula for aluminium oxide. In simple terms, you write it as Al2O3. So that is an ionic compound. And it holds for Al2S3. That is sulfur. Remember that sulfur is below oxygen in group 6. So through this formula that I've given you so far, I've given you over 50 to 60 examples of ionic compounds. But that is not the end of the ionic compound that you can develop by yourself. We have several metals, the transition metals, which can also combine with, they are even more, they have low ionization energies, and so they can even donate more electrons than the group 1, 2, and 3 metals. So they can combine with so many non-metals in nature. So there are several compounds that when you do transition metals, you see the compounds that they form. They are all ionic compounds. But even apart from that, you can have radicals. You can have radicals also coming together to form ionic compounds. If I say radicals, what I mean is complex ions. Remember, we said when you have a whole molecule, 2 or more atoms coming together and then having a charge, that ion is called a radical or a complex ion. Okay, you can have a simple ion and then a complex ion combining by the electrostatic force of attraction to form an ionic compound. And you can have complex combining or attracting each other by the electrostatic force of attraction to form an ionic compound. Let me give a few examples of that. If I write a nitrate ion, NO3 minus, this will be called a radical. It is having a -1 charge. If I brought a potassium that has lost electron somewhere, plus to it, these two will attract each other by electrostatic force of attraction. So we have something we call potassium nitrate. And you know potassium nitrate, you've been using it in the house all the time, particularly you girls. When you are cooking beans, you drop it in there. Okay, sometimes when some of you are even eating orange, you scrape it on the surface, it makes it very sweet. We call it saltpeter. In Akan or in our most languages, we call it kang. That is an example. These stones, that's potassium nitrate, and that is kang. So kang is a salt, and that is an ionic compound between potassium and nitrate. So here, this combination or this attraction is between a complex ion, anion, and then a simple ion. We can also have something like this compound that I've written here. That is a complex cation. This whole thing has +2 charge, and it's combined with 2 chloride ions. This is -1. So -1 times 2 give me -2. When it combines with this, the bond between this and that is an ionic bond. So where in this example, once I have a complex anion combined with a simple cation to give me an ionic compound. Here, this example, this is a complex cation combined with a simple anion to give me an ionic bond. You can still write another example that where you have complex cation and a complex anion, and the bond there, you still have to be able to identify that it's what? Ionic bond. Specific example. Specific example is if I write that same thing, nickel, water, for, and this +2, I can give you cobalt, -2. Here I'm making use of transition metals because they are flexible in losing electrons and gaining electrons and all that. So here cobalt actually is +4. This is -1 each. Cobalt exhibits various oxidation states. Okay, so this is -1 times 4 will give me -4. This is just between +2 oxidation states. So the -4 here will cancel the +2 of this. I get a net of -2, and this -2 is combining with this. So this ions here tells me that this is an ionic bond. This whole thing can form a compound which is an ionic compound, where we have complex cation combined with a complex anion to give us an ionic compound. The bond existing between this and that is the ionic compound. But the bonds between these ones here, we will have to explain them. We are growing gradually. We'll be able to understand that these ones here are what we call coordinate covalent bonds. We'll get them. Thank you so much. That is not the end of ionic bond. Our next video will explain the physical properties of ionic compounds. Let's see that.